Google has given $1 million funding to Rust Foundation, and they want to migrate their legacy C++ code bases easily to Rust, citing the major security features that Rust provides. So does that mean that C++ is dying? Let's find out in this particular video. So welcome back to Coding with Bharat channel. So you might have heard from a lot of influencers out there that okay, these are the companies whose blogs you should follow, you should read, right? But no one tells you how. How do you go about understanding the blogs of these companies? So for example, this is one such blog of Google, right, which was released very recently, February 5th. And it talks about investing $1 million in Rust Foundation to improve interoperability, right? Now, to anyone new to this world, you would not even know what interoperability means. And you would not be able to understand why this is happening or what are the memory issues being cited for C++ in this particular article. So that is the exact gap that I'm trying to bridge with this new series of mine, where I'll try to take up some of the articles or some of the blogs that these companies write and relate it to your software engineering in general and try to explain them from scratch so that even someone beginning in this world can actually get the grasp of what is happening out there in the world. So if you go through this particular article, you will check the link in the description as well. It talks about that C++ has some major security issues or some major memory challenges, right? And that is why what Google is investing in is to migrate or to easily migrate in a way codes from their legacy codes from C++ to Rust, right? And they want to do it in a smooth fashion. But being a big company, they cannot just directly go in one shot and migrate everything. That would be super disastrous. There would be new bugs introduced, there would be new problems, right? And that is even not possible. So the approach that happens generally in such companies is to take piece by piece, change that piece's part from probably C++ to Rust, right? But to maintain the code in this middle section where both the languages exist, you need something known as interoperability. So interoperability simply means that these languages should coexist and interact with each other segments of code and still work perfectly, right? So if you actually go through this article, it says that there are a lot of government agencies as well. So probably US government agencies who are focusing on security, and they have cited that C++ is a slightly memory insecure language. We'll dive deep into what that means, why it is memory unsafe. But let's first just get this article over with, right? So yeah. So basically, further, it also talks about that, okay, there are some existing legacy C++ code bases that they have, and they want to support interoperability. And they have already been doing it for the Android part of their code base, right? So they have already been doing it, and Rust provides good benefits already with Android. So for Android, they have been doing it, and they want to do for the remaining portions as well. And that is why this investment has come into the picture. Okay. But the main question still remains unanswered from this article. What are the major security issues that we are talking about here? And have there been some attack, or are they just theoretical issues? So let's dive deeper into it. I'll explain first what challenges exist with C++. We'll look at one of the attacks also that happened with C++ in a famous library known as OpenSSL. Finally, I'll take that remark that is C++ dying, or should you as a developer not learn C++ at all? So yeah, just stick to it and let's continue with the first part of the discussion. Okay, before we start jumping into the problems, the memory problems that we face with C++, first let's understand how the memory is organized in our operating system, or particularly in our RAM, when we run a program, right? So when we run a program, there are four components of our memory which are there. The program code, first of all, is loaded into the RAM, that is program code. Then static variables or the global variables that do not have a scope, they are first of all declared inside a global portion of our memory. So you can imagine the entire RAM, there is one section that is assigned to you. In that one section, first you put your code, you put your global variables, and then you have your call stack where you declare your local variables. So any variables that you declare with int x, let's say any of the static fixed variables like even an array, even an integer, right? And those kind of structures, those all go into stack. Now, any of the dynamic variables that you declare with the help of pointers, what happens is they are generally declared in a third or fourth portion known as heap, and the location where they are declared in the heap is generally stored in pointer variables that we have, and those pointer variables are in fact declared in our stack. Okay, so just to keep the memory model clear, global variables first of all declared in your global portion. Any local variables that you declare in a stack. Then any of the dynamic variables that you declared, those dynamic variables will lie in heap, but the pointer for that would lie in your stack. Okay, so that is how a generic memory function works. Okay, moving on. So what are the problems that we face in C++ that cause security issues? First, so there are two kinds. First of which is known as the spatial problem. So first of all, what is spatial problem, right? Spatial problem is that, okay, in C++, if you are declaring something in the memory, right, declaring something in the memory, you do not generally check whether whatever you are accessing is within that memory limit or not. For example, if you declare an array of size 10, ideally you should just be allowed to access those 10 variables that are there at each of the array positions. If you try to access some 11th variable or 12th variable, which is spatially, what does spatially means? Like location wise next in line, but it has not been declared, ideally there should be an error, which is not there in C++. So I have written a small code to illustrate this example. Let's say we have declared a vector of size 5 having 1, 2, 3, 4, 5 variables. And what I try to do, first of all, just go to the 9th position and put a 110 there. Right? I went to a 9th position and declared 110. Now what I'm doing is I'm going and iterating from 0 to less than equal to 10. So 11 times and printing all the values. So expectation ideally is, even if you assume that, okay, we have 9 values till 9 and you have assumed that anything inside it is 0, then also accessing the 11th one should be a problem, right? So yeah, but if we try to run it actually, so G++ and then I'll run it. So you'll see that it actually prints out all the values, right? Because of this, there have been security vulnerabilities in a lot of libraries. This small thing, it might look very small to you, but we'll also take up a case of the Heartbleed attack that happened recently on the OpenSSL library. That also exploit this small problem, that is unbounded access of variables. Second kind of issue is temporal issue. What is temporal issue? A variable was declared. Now, that variable scope has been completed, right? So that variable has, wherever it has to be used, it has been used. But if somehow we get to know the memory location of that variable, we can access that variable. Plus, we can access everything around it also, right? Because C++ doesn't prohibit you from going to a particular position and taking the value, right? So for example, I've written a small piece of code here. Let's say we have this create users function. What it does, it creates an array of size 2, right? And the initial part of the array we are storing in a pointer. The address of the initial location in the array we are storing in a pointer. Okay, what I'm doing, I'm saying go to the 0th position, put 42, go to the first position, put 44, and I'm simply returning this pointer. Now, ideally, this array is declared in this create users function, right? And the logic of scope says that if something is declared in a function, that can only be accessed in that function, right? And you should not be allowed to return it like this. Just giving the memory location of the first element, that is what you are passing, right? Now the user function can actually take these values out, right, without you intending them to do it. So for example, if I get this value in a pointer and then try to print that value and the next value, I'll be able to get the corresponding results. So if I do dot slash a dot out, you can see that 40 to 44, the exact values that I put here, are accessible even outside the function that declared those values, right? This is a this could be a potential major problem where, let's say, you have created a user's ID. So whatever the user's ID was or whatever the user's password was, you were keeping it somewhere. Now you have used it and you have just removed the references to it. But still, what happens? There is some part of your code which knows the memory location where that password was. And now, some other piece of API which any user is calling is trying to fetch some random junk values. But in those junk values, is able to fetch that particular portion of the memory and see your password. These are the like things how attacks are made out of these spatial and temporal issues, right? That okay, something is there in the memory that the hacker needs to take. Now he'll explore what kind of APIs are available and what I can exploit to get some extra values near the location of where I'm accessing. Okay, so let's dive deeper into the Heartbleed issue, right? The attack that actually happened, and see what actually caused it and how spatial issues are actually very, very problematic. Okay, so let's talk about the Heartbleed bug. So it was a vulnerability in an OpenSSL library. So if you are aware of HTTP versus HTTPS, right, you would have seen that in HTTPS websites we have a lock at the top, right? How it actually happens in the background is using certificates, right? And those certificates are generally using SSL as the protocol behind it. So SSL is nothing but secured socket layer, right? That is what they are using to establish a connection and actually make the transport happen. Okay, so the OpenSSL library, which is the main library in question here, that is an encryption software which is used by almost every company in the world to make SSL happen for their systems. Now, with OpenSSL libraries, there was a concept of heartbeat. Heartbeat is a common concept that, like, you would be aware of if you have been there in software industry for a while. What is a heartbeat? If there are two systems, one system wants to know if another system is alive or not, then what it does, it sends a heartbeat or a small message to the second system. The second system echoes back the same message, right? So for example, if first system says ABC to the second system using packets, the second system also responds with ABC, and that is how the first system knows that okay, this server is still alive. It's generally a very short message. Now, what actually happened in this OpenSSL, this heartbleed bug, is that there were no length checks on the message. So typically, a heartbeat message consists of a single message, right? And a length corresponding to it. That okay, if the message is ABC, the length is, let's say, 3, right? It's in bytes, but I'm just saying it in as 3. Okay. Now, typically what the server side of the OpenSSL, actually the client side of the OpenSSL would do is copy that string into somewhere in the RAM and then return those many bytes back as a heartbeat. So that is how the typical system used to work. But now what happened, if we go to the actual article details, so it talks about what SSL is, what OpenSSL is, right? So yeah, so basically this is how it used to work, that if there is an honest user and there is a server, the honest user used to actually say, ask the server that are you there, and the word is this, like banana. If you want me, if you want to tell that you are alive, you have to respond with this word, and it is of 6 characters. And the server would respond with that, okay, yes, your word is banana. So now they know that, okay, this is the server which read my message and responded back with the correct reply. Okay, but now what would actually happen, that the user of this server can actually ask you that, okay, my magic word is, let's say, giraffe, which is very small word, but it is 100 characters long. So what the server would do, it would store that message in RAM, right? And it is written in C++. So it would not check that those 100 characters which it needs to pick, and it will pick up the 100 character equivalent bytes and send that back. So actually the response would look like giraffe followed by the few extra characters. And in that, there is a chance that some of the other users, if they had given their usernames or passwords to this server, then that username or password or credit card information for that matter would be stored somewhere in the RAM. If an attacker can do this a few times, right, and try to get the different bytes and then try to brute force it and see if it has passwords or not, then he might be able to get onto something. So yeah, this is the brief of how the Heartbleed bug used to function. So yeah, so there is a person who actually was able to figure it out. So it tells the entire story. So I'll link this article also in the description. You should be able to understand it well. If you are lost, feel free to put a comment, right? Okay. It also tells you that, okay, have there been any successful attacks using this bug? So answer for that is yes. There was an attack on a virtual private network service, right? It was not a named organization, so it did not happen in one of the top companies, but someone did exploit this particular bug and was able to get some data. Actually, if you see which companies were affected by this bug, so you'll see that OpenSSL is being used by almost everyone. So Apple, Microsoft, PayPal, LinkedIn, eBay, Twitter, right? Almost all of the companies. Banks got safe because they have extra layers of security here. Okay. But essentially, all of this to prove the point that why Google is investing, because there are no out of bound checks as part of spatial memory. Plus, there are no temporal checks also in C++ inbuilt in the language, right? Obviously, does that mean that C++ is dying? No. People can write safe code if they make sure that all the particular checks are put into consideration. So actually, if you see, there is an article here which talks about what are the memory safe practices, right? So yeah, first thing it says that you always should null out any pointers when you are freeing the memory. So when you are making sure that, okay, this variable is now no longer needed, you just put it as null, so that by any chance, if someone gets this particular memory location, he's not able to access it. First of all, he is not able to get that memory location altogether. Second, it says always you should perform out of bound checks. So you should check that, okay, if your string is just 3 characters, you should just return 3 characters and not more than that. Yeah, so these were some of the like things you can consider. So I'll also link this particular article in the description. You can read it out. So if you want to write memory safe code, you need to consider these things. So it can be written with C, it can be written with C++, right? But since now we are dealing with legacy code, like for these companies, it is much easier to migrate it into a more safe language than, let's say, going ahead and fixing all of those things, right? Yeah. So that is about what Google is operating and why Google has invested 1 million in Rust. There are a few things that are still left unanswered here. There are a lot of different, you'll say, bugs that actually occur with these memory challenges, like double free bugs. Then there are things like dangling pointers, right? So I cannot go into depth of each of them. Like even if you see here, it talks about it talks about stack exhaustion and heap exhaustion vulnerabilities, right? So memory related, there are thousands of vulnerabilities that can exist. I've tried to put forward the Heartbleed Bug, and I've tried to also talk about two of the major challenges, spatial as well as temporal. If you want more, you can read about these things in more depth, right? Second thing that we have not covered that much is how Rust solves all of these issues. So we have not dived deeper into the logic of how Rust does it. But yeah, again, for that, understanding that, there would again need to be a lot of other, you can say, topics in programming that we would need to do well with. Specifically, we would need to talk about garbage collectors and how memory is cleaned up. Then we would also need to talk about the concepts of ownerships and borrow checks in Rust, right? So that will again become a very long video. So I've tried to keep it short so that you get some new ideas as well. Plus, you get interested in the topic and are free to explore more. Okay. If there is another article that comes in the future which talks specifically in depth of Rust, I might make a video out of it as well. Or if you guys think that you would like to know that, feel free to put it in the comments and I'll take it up. Great then. If you like this new form of series, just make sure that you let me know with a like and do comment out what other articles you would need me to talk about. And yeah, if you're new here, do subscribe to the channel and said see you guys in the next one.